All right, so we just went through glycolysis. Now we're on to stage 2, which is pyruvate oxidation followed by citric acid cycle. All right, here's an overview of what's going on, and I'm going to back up here. So reading a diagram like this is a valuable skill. So what I want you to do is I want you to pause this video and try to explain what on earth is going on. I want you to explain first from the position of the carbons. So each one of these gray little circles up here, this is a carbon. So we're starting off with pyruvate. Remember, we broke down glucose into 2 of these pyruvate molecules. Now we're just going to follow one of these pyruvates through this next section. So follow the carbon. That's what I want you to do first. Pause this, do that, and then I'll do it as well. Okay, the first thing that you're going to see here is that right off the bat, one of these carbons gets broken off, boop, and released as carbon dioxide. In doing that, that actually helps reduce NAD+, turns that into NADH. And so right from this step, pyruvate oxidation, which is where it's getting its name, it's being oxidized, we have NADH right here, which we'll use as an energy source later on. Now we see this other character coming in here, CoA. So CoA, this is an enzyme, and it's going to bond with these other 2 carbons to form this product, acetyl-CoA. So we started with pyruvate. Thanks to coenzyme A, we actually have acetyl-CoA. And from here, it would get transported into the actual mitochondrial matrix. So here's our big old, ooh, that is an ugly mitochondria, sorry. But here's our mitochondria with the folds here. So it's actually gotten transferred in. Now inside the citric acid cycle, you see that these carbons are going to get broken off one at a time here, and they're going to leave as CO2. So the original carbon that we started with from the pyruvate and originally from the glucose, by the citric acid cycle, it's gone. Thanks, Cortana. That's what I wanted right now. So now I've gotten rid of the carbons, and actually in doing that, I have reduced more NAD+, and I've also phosphorylated ADP, so I've created ATP. I've also reduced FAD into FADH2. So taking this pyruvate and breaking it down through the citric acid cycle, I've made these products right here. I've gotten rid of this product right here. So again, following the carbon, we lose 1 carbon right off the bat before acetyl-CoA is formed. Then the other carbons are lost as carbon dioxide. So that's where the carbon went. Where did the energy go? Well, the energy originally in these bonds, some of that got used to form NADH. Okay, some of that got used to form NADH down here. Some of that got used to form ATP, and some of that got used to form FADH2. So the energy is actually starting to pay off now, and it's being used to build up NADH, ATP, and FADH. Those are our batteries. They're our energy storage. All right, step A, pyruvate oxidation. So in this step, pyruvate is converted into acetyl-CoA. So again, this is the same process we just did. It's from a different angle. So here we go. We've got pyruvate hanging out in the cytosol, the cytoplasm. That has gotten transferred and turned into acetyl-CoA inside the mitochondrion. I think on the last slide I said that happens before it goes into the mitochondrion. In that case, I was wrong. That's my bad. So it gets acetyl-CoA actually gets formed inside the mitochondrial matrix. In forming this stuff, it is also producing CO2. It's taking NAD plus and it's charging it to NADH, and then coenzyme A is coming in here. Step B is the citric acid cycle, or Krebs cycle. So this is happening inside the mitochondrial matrix. Acetyl-CoA is getting turned into citrate, which is where it got its name from, and that's getting turned into CO2. For these ones, acetyl-CoA is really important for you to know. Citrate is known as an intermediary, so they probably would not ask you to know that. And then also CO2, you should know. You should also know that this is happening inside the mitochondrial matrix. They could ask that in a sneaky question like, what would, which of the following is correct? And then one of the options talks about the mitochondrial matrix. So they expect you to know that it happens inside that area. Net gain of this, we gain 2 ATP, 6 NADH, and 2 FADH2. These two in purple, these are electron carriers. Okay, this diagram here, again, you don't have to know it, but it would be fair game for them to ask you a question on it. In fact, on one of our quizzes and in the Raven and Holtzclaw book, you've seen this diagram before with more or less detail than this. So each of these steps on here, you're never going to have to know all these unless you go into cell and molecular bio. Then you'll have to know all of them. But what you would be expected to be able to do is to read through this and say, okay, right here at step 3, isocitrate is getting turned into alpha ketoglutarate. You probably wouldn't have to pronounce that. And that process is taking NAD plus and reducing it to NADH, which is also making CO2 as a byproduct. That was a good voice crack captured on audio for you. So you might have to read some of these steps, or it could say what's happening in step 5 here. So you'd have to end up saying, well, during step 5, ATP is actually being made. All right, summary of citric acid cycle. What's more important for you to know? You go from pyruvate to acetyl-CoA all the way through the citric acid cycle. And out of that, you get ATP and NADH. You also get CO2 and FADH. This is a byproduct. It's waste, and it leaves the cell. These other ones, these little guys, are electron carriers. They'll get used later on. And ATP, of course, makes energy or stores energy for the cell. So we can use that right away.